All right, so we are going to be discussing the autonomic nervous system today, and then we'll get into the special senses afterwards. The autonomic nervous system is one of my favorite topics because really it shows you how we are supposed to be functioning on a day to day basis. And you can have one system on and the other one is turned off throughout the day, and we switch back and forth based on needs. So it's a fight or flight or a rest and digest response. So you can have one of those activated at a time if you like the fight or flight if you are running late, or if you're trying to get away from a lion is one of the examples I use on a regular basis. Or it's rest and digest, like if you're sleeping or you're trying to digest your food, of course, to repair different systems. And then we'll, of course, get into the eyes and vision, which we're going to continue on through Thursday, as well as, well, I mean, that's going to be the last topic, essentially, the eyes, ears, and special senses. So let's start with the autonomic nervous system. So we've gone through the central nervous system. We did the peripheral nervous system, talking about the sensory versus motor divisions, and then the somatic versus the autonomic. Well, somatic is the conscious. It's what is controlled, your muscles, how you walk, how you move, you sense your surroundings, etc. The autonomic nervous system is going to be more for your internal organs. So things that you don't really have to consciously control, your body, your subconscious mind is going to do all the heavy lifting here. So telling your heart to beat, how much, if it needs to speed up, slow down, increase its intensity, its strength, or it needs to conserve more energy. So we're talking about sensation, but also effect. Okay, so in this, we're gonna see the effectors creating the somatic or the autonomic nervous system. Though you're getting sensory nerves from the sensory division, they're going to go into the brain and send a signal. The autonomic nervous system is going to be the effectors. It's going to be controlling those systems, those pathways. Okay, so we're going to discuss a couple different routes that they take. And the autonomic nervous system, the sympathetic and the parasympathetic, are going to innervate every single organ in the body with both of the sympathetic and parasympathetic. However, the way that they get there is going to be completely separate. So the sympathetic division is going to be from the thoracic region, whereas the parasympathetic is going to be from either the sacral region or from the cranial nerves. And so we learned about the cranial nerves last week, and if you review those cranial nerves and find out which ones have a motor effect, you'll see that almost all of them will have some sort of parasympathetic interactions with the body. A couple of them are somatic, but almost all of them are parasympathetic. So the sympathetic nervous system is going to be for your fight or flight, whereas your parasympathetic is going to be your rest and digest. So the sympathetic is like a sigma sign, so a backwards E, and then the parasympathetic you'd use a P, and then that backwards E. Okay. So the cell bodies in the nervous system, we talked about the common neuron, which is going to be the multipolar cell body. So you have several dendrites coming from the cell body, and then you have one axon that travels, and it has a myelinated axon that releases acetylcholine at like the skeletal muscles, where you will then stimulate a contraction of those muscles. So it's an excitatory or a stimulatory effect on that effector organ. Whereas the parasympathetic and sympathetic systems are going to be a bit more complicated than that. We're not going to have just one neuron to get from the central nervous system to that peripheral nervous system. We actually are going to have a two-neuron chain throughout the sympathetic and parasympathetic regions. And how they react and how they are divided are going to be dependent on what organ they're going to, if it's sympathetic, if it's parasympathetic, and then we're going to see that there's different neurotransmitters that are released that are going to dictate if it's a stimulatory or inhibitory effect. So not all neurons are going to stimulate an action potential. Some neurons are actually going to take the cell, whatever it's going to, farther away from action potential, thus decreasing its action. Okay, so for example, in the sympathetic region, we're going to send a signal to the heart that can, during exercise, or if you're running away from a lion, what would you want your heart to do? You want the heart rate to increase, you want the pressure to increase, so your blood pressure increases, your heart rate increases, and your output will then increase. So this would be a stimulatory effect to the heart. The parasympathetic is going to also go to the heart. However, when you're in a rest and digest mode, you need to increase your heart rate. Okay, so if you're trying to fall asleep, does your pulse go up or down? Well, it should definitely be going down, so that you can rest and recover and not utilize energy that you do not need to be utilizing. So the effect there would be a negative effect. It takes it farther away from that action potential, so it slows down the heart rate. Okay, but you can also have parasympathetic activity that is going to stimulate the body, such as the digestive tract. So you can stimulate a release of hydrochloric acid in the stomach so that you can digest food that you just ate. Whereas the sympathetic system would decrease the amount of hydrochloric acid being produced in the stomach because you're in that fight or flight mode. And when you're in that fight or flight mode, do you need to be worrying about the food that's in your stomach? No, because if you don't get away from the lion, you're going to be the food inside his stomach. So that's what you're worrying about. Fight or flight, get away from the immediate danger. Parasympathetic, rest, relax, heal, repair itself. Okay. So we're going to follow this the system and figure out how exactly those neurons get to their effector, why the two neuron pathway. So it's always a two neuron pathway, except when it goes to the adrenal medulla, which acts like a secondary neuron. Okay, so you release acetylcholine from that first neuron that comes from the thoracic region to the adrenal medulla, and then you release norepinephrine and epinephrine into the bloodstream, which is going to be your endocrine system, and that acts as a systemic neurotransmitter, essentially. So those epinephrine and norepinephrine, which are steroids, are going to go and find every cell in the body that has a receptor for epinephrine and norepinephrine and activate some change in that cell, which in the heart could increase the heart rate. So this would be a longer lasting than an initial neuron signal, because now you have it through the blood, and until they're all used up, they continue to circulate. Whereas the neuron, it goes and then it's off. Okay, so you get one signal and that's off, or you have to keep sending multiple signals. This, you get a signal and then it is that constant flow for several minutes, even hours. Okay, so we'll come back and discuss those, but two neuron chains, except for the sympathetic system, where it goes to the adrenal medulla, where the adrenal medulla acts as the second neuron, but it releases its neurotransmitter into the blood instead of sending it down an axon, so that it's a systemic sort of change in the body. Okay, so again, the parasympathetic, digest, rest. The sympathetic would be fight or flight. This is more of an example of where those neurons are going to be coming from. So the parasympathetic, you're going to get the vast majority of the innervation to the organs from the cranial nerves. So the cranial nerves coming from the brain and the brain stem are going to go out through 3 or 4 different cranial nerves. The one that serves the most organs will be the vagus nerve, which is cranial nerve number, well, if you go back through 000 to touch and feel very good velvet, okay, it's actually cranial nerve number 10, your vagus nerve, which is also known as the wandering nerve because it travels from your brainstem through your entire core. So it innervates the anterior, the superior 2/3 of the digestive system. And then the last third is going to be from the sacral plexus, which is coming from the sacrum, the sacral region. And that'll go to your bladder, to your genitals, and to the inferior portion of the large intestines. Okay, so the sympathetic is all going to come from T1 through L1, L2. Okay, so here's L1, L2. There you go. That's where you get all of your neurons for the sympathetic system. So what's going to happen is the parasympathetic is going to come from the cranial nerves. They're going to have a long first neuron. It's going to synapse within the walls of that organ or very, very close to it. And then it's going to have a very short secondary neuron that goes and innervates with the organ itself. Whereas the sympathetic system, you're going to have the neuron come from T1 through L2. It's going to exit the spinal cord, go through what's known as a sympathetic chain ganglia. So it's the sympathetic chain is found along the thoracic rib cage, and you're going to get the secondary neuron that is going to come from here and go to the organ itself. Okay, so the eye is going to be innervated by both the sympathetic from like T1 and the parasympathetic, which would be from the optic, the oculomotor, which would be cranial nerve number 2. And so you have both the systems interacting with the eye itself, so that you can balance it. So either you contract or constrict the pupil, or you can dilate the pupil. You can't do both at the same time. It's either one is on or one is off. Okay. So each of these organs will be innervated by both systems, but one will be turned on, one will be turned off. So in the sympathetic region, you're going to have a shorter first neuron and a longer secondary neuron, because it goes from the rib cage out to that organ, which means that the second neuron is much longer than this one from the parasympathetic region. Okay, so the ganglia in parasympathetic, again, is in the walls of the organ, and in the sympathetic is going to be in the sympathetic chain ganglia. And so they go all the way up into even the cervical spine. And actually, you can get what's known as Horner syndrome if a tumor impinges on the sympathetic chain. And that can cause a drooping of the eyelid on that one side. And that can be one of the early signs of lung cancer. And that's something that if you see an eye drooping, well, you want to look at several different possibilities. Lung cancer would be one, stroke, aneurysm would be some others as well. Okay, so the divisions, you have sympathetic and parasympathetic. Dual innervation, all visceral organs served by both divisions, but cause opposite effects. Okay, so again, when we talk about sympathetic does not always stimulate. It can stimulate organs when it is beneficial for that fight or flight response, but it will also inhibit others when it is beneficial to divert energy.